Assalamualaikum warahmatullahi wabarakatuh and hi. I'm Afif and in this video, my friends and I are going to present to you the techniques of differentiation. This presentation is for our class, MAT 183 Calculus 1 and was prepared by our group members. So, these are our group members, Asfa Bazil bin Muhammad Rizal, Ahmad Afif bin Muhammad Udin, Burhanuddin, that's me, Muhammad Khairil Alfi bin Muhammad Iqbal, Jonathan Benjamin Kudumbal. First thing first, what is differentiation? Differentiation is a key concept in calculus that helps us understand how a quantity changes. It is mainly used to find the slope or steepness of a curve at any specific point. This is useful in many real-life situations, such as finding speed from a distant time graph or measuring how fast something is growing or shrinking. The result of differentiation is called a derivative, which tell us rate of change. In differentiation, there are 5 rules that we need to know. So the first one is power rule. Second rule is a constant rule. Next is product rule, quotient rule, and lastly is chain rule. This is the question that we're going to present to you. There are 3 questions, and I'm going to give Jonathan to solve first question.
Thank you, Afif. Now I will explain question 1a. In this question, we need to find derivatives of y equals square roots of 2x minus 1 times sine 3 minus x. So what we need to do first is we put d over dx for both y and square roots of 2x minus 1 times sine 3 minus x. And then we have to set number 1 and number 2 because we need to calculate each of these. So for set 1, d over dx times y, we just simplify dy over dx. And for the set 2, we just simplify d over dx, 2x minus 1 in bracket power by 1 over 2 times sine 3 minus x. So in this, we have u and v. So u and v, we have to find u prime and v prime. So in order to find u prime and v prime, we have to use a chain rule. So for u prime, we get 2x minus 1 in bracket power by minus 1 over 2. For u prime, we get negative cos 3 minus x. And then we will use the product rule and we only need to substitute in product rule. And then for the final answer, dy over dx equal negative square roots 2x minus 1 times cos 3 minus x plus sine 3 minus x over square roots of 2x minus 1. That's all for me. Now I will pass on to Afif.
Thank you, Jonathan, for the explanation just now. Back to me again. I'm going to solve one big question. That is, find dy dx for y equal to ln 5x plus 1 over cos 2x. So we want to put d over dx on both y and ln 5x plus 1 over cos 2x. So we got d dx y equal to d dx ln 5x plus 1 over cos 2x. Then we're going to divide it. So we got first set and second set. For the first set, simplify it, become d dx times y become dy over dx. So the second set is we take numerator that is on the top as a u and take denominator as a v. And then we're going to differentiate both u and v. So we differentiate u as a u prime equal to 1 over 5x plus 1 times 5. And we got 5 equal to 5x plus 1. And then we differentiate v as a v prime equal to negative sine 2x times 2. And we got negative 2 sine 2x. Then we're going to use a quotient rule to solve it. Why? Because we differentiate on numerator and denominator for division quotient, like over cos 2x. So we need to use quotient rule. And we substitute u, v, u prime, and v prime into the formula. And we got cos 2x times 5 over 5x plus 1 minus ln 5x plus 1 times negative 2 sine 2x over cos the power of 2x. And simplify the answer. And we got dy over dx equal to 5 cos 2x over 5x plus 1 plus 2 sine 2x ln 5x plus 1 over all the things. And we cos power of 2x. And that's all. This is how we answer for one big question.
Thank you, Afif. Next question 2. Find dy over dx for 2y ln 4x plus 3x to the power of 7 equal to 2 tan x minus y minus exponent to the power of x squared by using implicit differentiation. Given this equation, put d over dx in front of each and set d over dx 2y ln 4x as 1, d over dx 3x to the power of 7 as 2, d over dx 2 tan x minus y as 3, and d over the x exponent to the power of x squared as 4. You will done one first, differentiate 2y ln for x, u equal to 2y, differentiate u prime equal to 2 dy over the x. Then v equal to ln for x, differentiate v prime equal to 1 over x. We're using chain rule, u times v prime plus v times u prime. And then we will get 2y times 1 over x plus ln for x times 2 dy over the x, differentiate. The answer we will get 2y over x plus 20y, 2 ln 4x dy over dx. Then we do number 2. Differentiate 3x to the power of 7, we will get 21x to the power of 6. Then we'll do number 3. 2 tan x minus y, we'll differentiate it, and we'll get 2 sec square x minus y times 1 minus dy over dx. This simplify the answer, we will get 2 sec square x minus y minus 2 sec square x minus y dy over dx. Finally, we're doing number 4. Differentiate exponent to the power of x squared. Final answer will get 2x exponent to the power of x squared. Then we substitute 1, 2, 3, and 4 inside this equation. Back, then we will get 2y over x plus 2 ln 4x dy over dx plus 21x to the power of 6 equal to 2 sec square x minus y minus 2 sec square x minus y dy over dx minus 2x exponent to the power of x squared. Then put all the equation with dy over dx to the right and other to the left. Bring the dy over dx out. And finally, put everything to the right and dy over dx. Just let it to the left. We will get a final answer. Dy over dx equal to 2 sec square x minus y minus 2 x exponent to the power of x squared minus 2y over x minus 21 x to the power of 6 over 2 ln 4x plus 2 sec square x minus y.
Thank you, Ascar. So now for question 3. We need to use linear approximation to estimate the value of square root 63.98 minus 4 over cube root of 63.98 correct to 3 decimal places. Divided by 2 parts, which is part 1 and part 2. For part 1, square root of 63.98. The number is very close to 64, which is a perfect square, where square root of 64 is equal to 8. So we'll use x equal to 64 as the best value. We'll substitute it into the equation of f prime, which is 1 over 2x, the power of negative 1 over 2. Substitute 64 into x, get 1 over 16. Next, we'll find the dx, which is the difference in x. To find it, we need to minus 63.98 by 64, which will get negative 0.02. By using the formula of df equal to f prime x times dx, we'll get 1 over 16 times negative 0.02, which is equal to negative 0.001. And now we will add the change to the original value, which is add plus negative 0.001, which will get 7.999 as the answer. For part 2, using the same method as part 1, we'll use 64 as the best value. We'll get the value of fx equal to 1 and f prime x equal to negative 1 over 192. Using the formula of df equal to f prime x times dx, we'll get negative 1 over 192 times negative 0.02, which the answer is approximately 0.0001. Now, we add the change to the original value, which is 1 plus 0.001, which is 1.000 in 3 decimal places. So by substitute the answer for both parts, we'll get 7.999 minus 1.000, which the answer will be 6.999 in 3 decimal places.
For the conclusions, through systematic applications of differentiation techniques, our group successfully analyzed all 4 equations by identifying their critical points, classifying extrema, and evaluating the overall behavior of each function. The derivative offer deeper structural insight, enabling us to determine monatomic intervals, concavity chains, and the stability of solutions. Where analytical solutions were feasible, derivative tests confirmed their validity. Where solutions were more complex, linearizations and numerical approximations provided reliable alternatives. Overall, the derivative was not only a computational tool, but also a diagnostic lens, allowing us to understand how small change in input influence the system and how each equation behaves across its domain. This integrated approach produced a complete and coherent picture of mathematical dynamics underlying the problem.
Now, I'm gonna show you the references. We learned to solve the question mainly from our MAT 183 calculus 1 by our lecturer and we watch YouTube videos to do a revision and make us understand more on the answer, make us understand more to answer these questions, such as the organic chemistry tutor and Kevin Made Science. We even try to check our answers using Symbol Lab AI application to know where our mistake is, so we can answer it in correct way. So that's all from us. Thank you so much and have a great day. Bye.